What if I told you that there is a black hole so colossal that to match its mass, you would have to take the mass of the sun, multiply it by 1,000, then multiply it by 1,000 again, once more by 1,000, and then by 66? We're not talking about something merely big. We're talking about a cosmic entity so gigantic that its very existence seems absurd. Its name? TON 618. Now think about this. The black hole at the center of our galaxy, Sagittarius A, is already a monster with 4 million solar masses. But TON 618 doesn't have millions, it has 66 billion solar masses. A true cosmic titan that could swallow entire solar systems as if they were mere grains of dust. Its event horizon is so vast that light would take an entire week to cross it. This means that, within it, time and space simply cease to make sense. But the big question is, how can a black hole grow this much? Is there a limit to this type of entity? Or could it be that, in some remote corner of the universe, even more colossal monsters are waiting to be discovered? Black holes are unlike anything else we know in the universe. While planets and stars have a maximum size, a physical limit that prevents them from growing indefinitely, black holes operate under completely different rules. They have no tangible edge, no real boundary. In theory, they can grow forever, devouring everything around them: gas, dust, entire stars, and even other black holes. This means that, under ideal conditions, a black hole could swallow an entire galaxy and still remain hungry. Now think about this. If a black hole absorbs more and more matter, its gravity increases exponentially. With each piece of matter consumed, its event horizon, the region from which nothing can escape, expands. Imagine a snowball rolling down a mountain, accumulating more and more snow and becoming gigantic. That's how a black hole grows. There is no ceiling, no point of balance. It simply keeps growing as long as there is something to devour. But this raises a question. What happens when a black hole grows beyond any scale we can imagine? Is there a practical limit? Well, if we look at cosmic evidence, there are indications of black holes with such absurd masses that they defy any conventional explanation. This leads us to another type of black hole, one that may have formed in the earliest days of the universe. Long before the first stars shone, when the universe was still a chaotic, seething mass of particles and energy, something intriguing may have happened: the formation of so-called primordial black holes. Unlike the black holes we know today, which form from the collapse of massive stars, these would have been born directly from the dense energy fluctuations just after the Big Bang. And here's the most shocking detail. Some of them could be as small as a single proton while carrying the mass of an entire mountain. Now try to visualize that. Take a gigantic mountain, like Everest. Now imagine all that mass compressed into something smaller than a grain of sand. It seems impossible, doesn't it? But that's exactly what primordial black holes suggest. If these objects truly exist, they could be scattered throughout the galaxy, silently drifting through space, invisible and undetectable to us, except for the gravitational effects they exert on everything around them. And there's more. Some scientists speculate that these primordial black holes could actually make up part of the mysterious dark matter that fills the universe. If this is true, the answer to one of science's greatest mysteries might be hidden in these nearly undetectable objects. But before we go that far, we need to talk about the black holes we know with more certainty. Those born from the explosive death of a star. Not all stars have a peaceful ending. Some live for billions of years only to meet a violent and overwhelming fate. A gravitational collapse so extreme that it gives birth to a black hole. These are stellar black holes formed from the destruction of massive stars or the merger of neutron stars. And believe it or not, they are everywhere in the universe. The smallest stellar black hole ever detected has about 2.7 times the mass of our sun, while some can grow up to 150 times that mass. To get an idea of what this means, imagine holding a soccer ball. Now imagine that this ball has the weight of an ocean liner. That's the mind-boggling density of a stellar black hole, a colossal amount of matter squeezed into a tiny space, creating an astonishingly powerful gravitational field. And the most intriguing part? Some of these black holes may be closer than we think. Scientists believe our galaxy harbors millions of them, silently drifting through space. But if they're so hard to detect, how do we know they exist? The answer lies in their impact on nearby stars. When a stellar black hole is in a binary system, it pulls matter from its companion star, forming incredibly hot accretion disks that emit powerful X-rays, a true beacon in the cosmic void. But sometimes these lonely black holes don't stay lonely for long. In certain regions of the universe, where stellar density is extreme, collisions between black holes become inevitable, and that's when even more spectacular things happen. If a single black hole is already terrifying, imagine what happens when two of them meet. In some dense regions of the universe, where stars are born and die at a rapid pace, black hole collisions are more common than you might think. When this happens, a cosmic spectacle unfolds. The merger of black holes releases an absurd amount of energy, generating gravitational waves that ripple through the fabric of space-time. These gravitational waves, predicted by Einstein over a century ago, were first detected in 2015. Since then, scientists have observed multiple black hole mergers, some occurring an astonishing 17 billion light-years away. It's as if the universe is sending us signals from its deepest past, an echo of the titanic collisions that shaped galaxies. But here's the most astonishing detail. When two black holes merge, the result is an even bigger black hole, a true cosmic monster. Some of these mergers have created black holes up to 142 times the mass of our Sun. This raises a fascinating question. How large can these black holes grow? If we follow this logic, we could reach colossal black holes with millions or even billions of solar masses. And indeed, these giants do exist. Before we explore these cosmic titans, we need to understand how they form and where they reside. And the answer to that takes us to the heart of nearly every massive galaxy. If stellar black holes are already incredible, supermassive black holes are absolutely extraordinary. These cosmic monsters have masses ranging from millions to billions of times that of our Sun and are found at the heart of nearly every large galaxy. They are the true rulers of the cosmos, shaping the fate of vast regions of the universe. The most famous example is Sagittarius A star, the supermassive black hole at the center of the Milky Way. It has about 4 million solar masses, and despite its immense gravitational influence, it is surprisingly quiet. Unlike other supermassive black holes that ravenously consume matter, Sagittarius A spends most of its time fasting, without devouring large amounts of gas and dust. But that doesn't mean it has always been peaceful. There is evidence that, in the past, it fed voraciously, releasing powerful jets of energy. But how do these titans form? This is one of the biggest questions in modern science. Some astronomers believe they started as smaller black holes that grew over billions of years by consuming stars, gas, and even other black holes. Others suggest they may have formed directly from massive collapses shortly after the Big Bang. Either way, one thing is certain. They are not mere spectators in the universe. They shape the galaxies around them and dictate the pace of their evolution. And if you think supermassive black holes are impressive, wait until you learn about those that shine with an absurd intensity. Some are so active that they outshine all the stars in their galaxy combined. It may seem contradictory, but some black holes are incredibly bright sources of light. This happens when a supermassive black hole is hungry and starts devouring vast amounts of surrounding matter. This process forms an accretion disk, a scorching spiral of gas and dust spinning at absurd speeds, releasing monstrous amounts of energy. The result? An active galactic nucleus, or AGN, active galactic nucleus, which can shine brighter than all the stars in an entire galaxy combined. Imagine an ordinary light bulb. Now multiply that brightness by trillions. That's what we're talking about. Some active galactic nuclei, like quasars, emit jets of particles moving at nearly the speed of light. These bursts of energy can stretch for hundreds of thousands of light years, shaping their surroundings and influencing the very growth of their galaxy. One of the most astonishing examples is the Quasar 3 C273, located about 2.4 billion light years away. This object shines so brightly that, despite its incredible distance, it can be seen through amateur telescopes here on Earth. To put this into perspective, it would be like a firefly being visible from space. The scale of energy involved is simply mind-blowing. And if you think this is already extreme, wait until you learn about black holes that reach billions of solar masses. Some are so massive that they could swallow not just stars and planets, but entire solar systems without any effort. If supermassive black holes are already impressive, some specific cases challenge everything we know about these cosmic monsters. Cygnus A and Messier 87 are two examples that show how black holes can completely dominate their galaxies, influencing their evolution and leaving visible marks on the universe. Cygnus A is one of the most powerful radio sources in the sky. At the heart of this galaxy, 600 million light-years away, lies a supermassive black hole with billions of times the mass of the Sun. The most astonishing feature is its relativistic jets, highly energetic particle streams traveling nearly at the speed of light, stretching for hundreds of thousands of light-years. These jets collide with the interstellar medium, forming colossal structures similar to shock waves propagating through an invisible ocean. Then we have Messier 87, which became famous for a special reason. It was the first black hole ever photographed directly by the Event Horizon Telescope. Located 55 million light-years from Earth, this colossus has about 6.5 billion solar masses. To grasp its sheer size, if it were placed at the center of the solar system, its event horizon would extend beyond Pluto's orbit. It is also known for launching an incredible jet so powerful that it can be observed even from Earth. Now, if 6.5 billion solar masses already seems like an exaggerated number, believe it, there are even bigger black holes. Some are so immense that they challenge even our best theories about how these objects form. And among these colossal giants, one stands out as the largest ever discovered, which we'll explore next. If supermassive black holes are already colossal, there is a category that takes everything to another level: ultramassive black holes. These cosmic monsters don't just have a few billion solar masses, they reach tens of billions, growing to such an absurd size that they seem to defy the very laws of science. Imagine something so enormous that it could swallow thousands of entire solar systems at once. These black holes are so large that their event horizons can stretch for hundreds of billions of kilometers. And the most astonishing part? Some astronomers believe they started growing in the early universe, continuously absorbing matter for billions of years without stopping. One of the most shocking examples is the black hole at the center of the galaxy Home 15A, with an incredible 40 billion solar masses. To put this into perspective, if the entire solar system were shrunk to the size of a coin, this black hole would still be larger than a football stadium. It is so massive that its gravity completely warps the space around it, creating a nearly empty central region within its galaxy, as no stars can survive too close to it. But as monstrous as these may be, there is still one black hole that surpasses all others. A colossus so gigantic that it challenges our very understanding of the cosmos, and its name is TON 618. There are giant black holes, monstrous black holes, and then there is TON 618. This cosmic colossus is not just big, it redefines what we consider immense in the universe. With an astonishing 66 billion solar masses, TON 618 is the largest black hole ever discovered, a true world devourer capable of swallowing entire solar systems effortlessly. Now try to picture this. If our solar system were a small coin, TON 618 would be the size of an entire country. Its event horizon is so absurdly vast that light would take about a week to cross from one side to the other. This means that inside this monster, time and space lose all meaning, becoming an unfathomable abyss from which nothing, not even information, can escape. But the most shocking part? TON 618 isn't just floating idly in space. It is a quasar, a black hole consuming matter on an unimaginable scale, emitting an energy output greater than trillions of suns. If it were possible to see it with the naked eye, it would shine brighter than any star in the sky. The big question is there something even larger hidden in the universe? Could TON 618 be just one among many invisible monsters we have yet to detect? Or are we witnessing the ultimate limit of what a black hole can become? What TON 618 teaches us is that the universe does not follow predictable limits. Just when we think we understand its scale, something even more colossal emerges to challenge our comprehension. But if gigantic black holes can grow to unimaginable proportions, this raises an even deeper question. How does it all begin? How does the chaos of the cosmos give rise to such powerful entities? To understand a colossus like TON 618, we must go back to the beginning. Some of these giants may have originated from extremely violent events, such as the merger of neutron stars. When two of these incredibly dense stars collide, the resulting explosion can be powerful enough to create a new black hole. And this story doesn't end here. If TON 618 is a true cosmic monster, imagine what happens when two of the densest objects in the universe crash into each other, unleashing forces that challenge even the laws of science. If you want to uncover more about this mystery, check out our previous video on kilonovas, events so powerful that they can forge gold, platinum, and, in the best or worst cases, black holes. And of course, subscribe to the channel and turn on notifications to keep exploring the most fascinating mysteries of the universe.